Hello all. Today we will be dealing with the lesson acids, bases and salt. This is lesson number 3 of your chemistry. So it's acids, bases and salts. Now under this one we are going to first study about acids. Okay. Acids have been derived from the Latin word which means acidus, and acidus is sour. Something which is sour is acidic in nature. You all know that if you take curd has what? It has lactic acid. It is sour. If you take apple, it has malic acid. It is sour. And if you take all the citrus fruits, it has citric acid, and that is sour. But you can't taste all. Many of the acids are harmful, so you can't taste all. So when we come to the definition of acids, acids are those substances which furnish hydronium ions in water. Acids are those substances which furnish hydronium ions in water. Now, if we take the example of HCl, HNO3, H2SO4, you will see that all the acids have an important part, and that is H. Okay, so it is HCl. H is an important part. That means all the acids have an important constituent, that is proton, which is H plus. Okay, so it has HCl, HNO3, H2SO4. Fine. Now, when I say about acids, it furnishes, what did I say? It furnishes hydronium ions in aqueous solution. Let us take the example. If I take HCl, it ionizes to give H plus and Cl minus. Okay, now this H plus ion doesn't have an independent existence. This H plus ion doesn't have an independent existence, which means the H plus ion will form what? It forms an hydronium ion in the aqueous solution. H plus ion doesn't have an independent existence. It combines with a molecule of water and forms an hydronium ion. Now when I come to the structure of hydronium ion, it is HOH. This is water with two lone pair of electrons. Water with two lone pair of electrons are there. Now, one of the lone pair of electrons are coordinated to this H plus ions, and then what we have the identity is an hydronium ion with those as H3O plus. Okay, so what we have concluded, what is acid? Acids are those substances which furnishes hydronium ions in an aqueous solution. Okay, when we come to the types of acid, the first classification of acid is dependent on the source. It is dependent on the source from where this acid is obtained. If I start with, the first one is organic acid, and the other one is inorganic acid. So depending upon the source, types of acid, depending upon the source, so what are they? Depending upon the source, organic acid and inorganic acid. Inorganic acids are also known as mineral acids. Mineral acids. Fine. Now, all the acids which are obtained from plants or all the acids which are obtained from nature, they are all organic acids and they are weak, which means all the acids which are obtained from nature, especially the plant source, they are all weak acids. If I give an example, it is citric acid, as I told you earlier, citric acid, tartaric acid, oxalic acid, formic acid. So what are these acids? What are these? There are many. If I write some few examples, citric acid, tartaric acid, oxalic acid, formic acid, and then acetic acid. So these acids are obtained from the plant source or they are present in nature. You all know where the citric acid is present. It is all present in the citrus fruits, as I told you earlier. Tartaric acid is present in tamarind, oxalic acid is present in tomatoes, and formic acid, it is present in the sting of the bees. So, these acids are all weak acids. We will see what are weak acids. When I say weak acids, they are those acids which do not ionize properly or their ionization is very weak or they give less amount of hydronium ions. So, and if I say weak acids, what we say that weak acids furnish what? Less amount of hydronium ions when you put it in water. And you can also guess what the strong acids means. Strong acids means, what are strong acids? Strong acids are those acids which produces more amount of hydronium ions. For example, if I write down HCl, hydrochloric acid, in the aqueous solution, it completely ionizes. And then it gives you what? Hydronium ion and Cl minus ions in the aqueous solution. The amount of hydronium ions are more, concentration is more because it has completely ionized. But in case of weak acids, their ionization is very weak. The ionization is very weak, they produce very less amount of hydronium ions. Fine? Now, so what we were dealing with? We were dealing with what? We were dealing with the types of acids. So we have seen what are organic acids. Now we come to inorganic acids. Inorganic acids are also known as mineral acids. Inorganic acids. Inorganic acids. What are inorganic acids called? They are also called mineral acids. Why they are called mineral acids? Why are they called mineral acids? Because these acids are obtained from minerals. For example, I write down HCl, H2SO4, HNO3, right? And if you see, in the inorganic acids, carbon is not there. Carbon is not there except for carbonic acid. Except for carbonic acid, where you can see carbon. Fine? But in organic acid, because source क्या है? Source plants है. Source is from nature, so carbon is an important constituent. So organic acids mean carbon is an important constituent. Fine? But in mineral acid, you see, you don't find carbon, right? Except for carbonic acid. And most of the mineral acids are strong. There are weak also, like carbonic acid is a weak acid, H2S is a weak acid. So what we interpret? Most of the mineral acids are strong. Carbon is not a part of their constituent in the molecular formula, except for carbonic acid. There are few there are few mineral acids which are weak. Fine? Okay. Now, when I say about mineral acids, I can also explain to you about hydroacids, and oxyacids. Hydroacids and oxyacids. I think you can make a guess what are hydroacids and what are oxyacids. Hydroacids are those which have the hydrogen elements in them, no oxygen. This is a hydroacid. This is a hydroacid. This is a hydroacid. But in an acid, when you have an oxygen atom associated with it, we call it as oxyacid. HNO3, it has oxygen. Sulfuric acid, it has oxygen. So these are all oxyacids. Fine? So what we have seen the classification of the acids. One is your naturally occurring acids, which are organic acids. The other is what? Inorganic acids. Inorganic acids are also called mineral acids. And there only we have seen what? Hydroacids and oxyacids. Suppose it can come in the question, I write down 2 examples of oxyacid. So you can write any acids which have oxygen in them. Write 2 examples of hydroacids. Okay. Now what we have to do is, we will come to the topic that is basicity. Basicity of an acid. Basicity of an acid. Basicity of an acid. Before I introduce this term basicity, you tell me when HCl is taken in an aqueous solution, or if I take hydrochloric acid, you know what is hydrochloric acid? See, there is a difference between hydrogen chloride gas and hydrochloric acid. Hydrochloric acid means you have dissolved HCl gas in water. You have dissolved HCl. HCl gas cannot be said as acidic. Because HCl gas H plus ions furnish नहीं कर रहा है. लेकिन this HCl in water, there it shows acidic solution, acidic property. So if I take, so what I am writing is hydrochloric acid. So if I write down hydrochloric acid, of course, that gives an idea that it is an aqueous solution. You tell me how many H plus ions it furnishes. How many H plus ions it furnishes? It furnishes 1 H plus ions, which I do write as what? Hydronium ion. ठीक है? इसमें एक H है, इस एसिड में एक H है, this acid has one H, so it furnishes how many hydronium ions? It furnishes single hydronium ion. And I do write down aqueous, that makes it more specific. Okay, now when I take sulfuric acid, you tell me how many ions it furnishes? How many ions it furnishes? It will furnish how many ions? It will furnish 2 ions, no? There are 2 H plus ions, so it will furnish 2 H plus ions in an aqueous solution. Fine? Now can you relate? What is it? Basicity of an acid is the number of hydronium ion an acid furnishes in an aqueous solution. For HCl, what is the basicity? The basicity is 1 because it furnishes 1 hydronium ion. For sulfuric acid, the basicity is 2 because it furnishes how many hydronium ion? It furnishes 2 hydronium ion. Likewise, we have acids whose basicity is 3. example of phosphoric acid. Let me draw the structure. H3PO4. It's H3PO4. How many hydrogens are attached to oxygen, which could be removed as H plus ions? So it is 3, right? So there are 3 H plus ions which could be furnished in an aqueous solution. So what is the basicity of phosphoric acid? It is 3. Fine. Now, when we come to the types of salt which the acid makes. Suppose, for example, if I write down monobasic acid. If I write down monobasic acid, example, HCl. Okay? So, if HCl is made to react with NaOH, you can identify the salt. It is NaCl plus water. It is a normal salt. Fine? Normal salt. Now, when I take H2SO4, look to the ionization process. This sulfuric acid ionizes in 2 steps. Let us see the first step. I write down H2SO4. Fine. If it ionizes and gives off 1 H plus ions, rather I write down 1 H2O plus ion, hydronium ions. And what is the anionic part remaining? It is HSO4. This is what? This is showing the removal of 1 H plus ion in the form of hydronium ion. Removal of 1 H plus ion. Fine. Now, you can also show the removal of the next H plus ion. Look to this carefully. So, in the first step, I have removed just 1 H plus. I am getting H plus removed. In what it is? Hydronium ion. What is the remaining part? It is HSO4 minus. Okay. In the second step, what does this HSO4 can do? It can remove the remaining H, and then that means, and you get what? SO4 minus 2. Fine. So from here, you can guess the 2 types of salt which is formed. Can you guess the 2 types of salt which is formed? The 2 types of salt, one is NaHSO4. NaHSO4. When do you get NaHSO4? When you remove 1 hydrogen. And the other one is Na2SO4. So, for a dibasic acid, we say we get 2 types of salt. One is an acidic salt. What is an acidic salt? The salt which has hydrogen element in it. When we take sulfuric acid and we are not showing complete ionization. The sulfuric acid का complete ionization होता तो पूरा hydrogen निकल जाता, right? So we are not showing complete ionization. Okay, and so what you get is, in the first instance, you get one salt which is sodium bisulfate, an acidic salt, and the other one where you show the removal of all hydrogen and formation of another salt which is normal salt. Acidic salt, normal salt.